In the realm of aquaculture, where nurturing aquatic life into a thriving industry is our goal, one critical factor towers above all others: the enigmatic water temperature. Its influence is so profound that it shapes not only the physiology and metabolism of our finned charges, but also their susceptibility to diseases. Today, we delve deep into this pivotal topic. Join us as we unravel the intricate relationship between water temperature and disease susceptibility in aquaculture. As we navigate through this journey, we will explore the delicate balance of temperature's impact on our aquatic wards, equipping you with the knowledge to ensure their health and vitality. But before we dive into the depths of this discussion, please take a moment to subscribe to our channel and hit the bell icon to stay updated with our latest content. Your support means the world to us. Now, let's embark on this enlightening exploration together. Water temperature, a silent sculptor of aquatic ecosystems, wields an influence over fish health that is both subtle and profound. As ectothermic creatures, fish lack the internal thermostat that mammals like ourselves possess. Instead, their body temperature mirrors the environment they inhabit. A deviation from the ideal temperature range, be it too high, too low, or fluctuating too rapidly, can send ripples of stress through their biological systems, leaving them vulnerable to a myriad of ailments. At the heart of this vulnerability lies their immune system, a complex network designed to safeguard fish against the relentless onslaught of pathogens. An optimal temperature range acts as the sweet spot for fish immunity, allowing this intricate system to perform at its best. Within this range, immune cells, the soldiers of the fish's defense army, patrol the body with vigor, identifying and neutralizing potential threats. Antibody production, a key part of the immune response, hums along, ready to counter any invading pathogen. Inflammatory responses are swift and efficient, isolating and eliminating troublemakers without major disruptions to the fish's internal balance. However, venture beyond this optimal range and the very system that shields the fish from harm begins to falter. Picture this in the unforgiving heat, where mercury levels soar beyond the fish's tolerance. The once robust immune system weakens, akin to a fortress under siege. The number and activity of immune cells diminish, antibodies drop in number and effectiveness, and the body's nonspecific immune defenses, such as mucus production, dwindle, leaving the fish exposed and vulnerable. Furthermore, the relentless assault of heat can trigger oxidative stress, sending harmful molecules, free radicals, rampaging through cells, damaging vital components and compromising the fish's overall health. On the flip side, picture the fish braving the chilling embrace of too low temperatures. Here, the immune system doesn't just slow down, it enters a state of near hibernation. Key immune cells become sluggish, antibody production grinds to a halt, and the fish's ability to identify and neutralize threats nearly ceases to exist. In this weakened state, the fish, transformed from a resilient fighter to a sitting duck, becomes highly susceptible to a host of cold water diseases. And then there are scenarios where the water temperature plays a game of hide and seek, fluctuating rapidly and unpredictably. These sudden shifts, whether upward or downward, pose their own unique set of challenges. The fish, caught off guard by these dramatic changes, mount a stress response, releasing hormones like cortisol that, while helpful in the short term, can temporarily paralyze the immune system, leaving the fish vulnerable during a critical moment. But the story doesn't end here. Water temperature's impact extends far beyond the fish, reaching the pathogens, the tiny organisms that hold the key to many aquatic diseases. Each pathogen has its own preferred temperature range, a Goldilocks zone where it thrives, replicates, and unleashes its full virulence. Many bacterial pathogens, such as Aeromonas hydrophylla, Edwardsiella tarda, Streptococcus agalactiae, and Flavobacterium columnar, find their ideal living conditions in warmer waters, becoming highly active and virulent during warmer seasons. Parasites like Ichthyophthirius multifilias, the infamous cause of white spot disease, flourish in these warmer temperatures, accelerating their life cycle and increasing their infection pressure on fish. Conversely, other pathogens like Aeromonas salmonicida, the culprit behind furunculosis, or Renobacterium salmoninarum, which causes bacterial kidney disease in salmonids, find their sweet spot in colder waters, becoming problematic during the colder months. Imagine this scenario: a summer day in a fish farm. The sun beats down, warming the shallow waters to near perfection for a particular pathogen. At this very moment, the fish, already stressed from the heat, becomes infected. With the disease taking root and spreading, the outcome is often dire. The fish, weakened by the heat and now battling a pathogen that's thriving in the warm waters, succumbs to the disease, highlighting the devastating impact of temperature on aquatic life. The relationship between water temperature and disease susceptibility is a complex interplay of multiple factors. Let's break it down into how temperature increases disease susceptibility. Firstly, direct immunosuppression. As we discussed earlier, extreme or fluctuating temperatures can directly suppress the fish's immune system. This means that even if the fish is exposed to a pathogen, its immune system might not be equipped to fight it off effectively, leading to illness. Secondly, increased pathogen virulence or growth. The temperature might be favorable for the growth and multiplication of the pathogen. Take, for example, the warm water pathogens we mentioned earlier. When temperatures rise into their optimal range, these pathogens can grow rapidly, multiply quickly, and cause diseases with greater severity. Thirdly, reduced barrier function. High temperatures or other stressors like low dissolved oxygen can compromise the physical barriers of the fish, such as the mucus layer or skin, making it easier for pathogens to penetrate and infect the fish. Fourthly, behavioral changes. Stressed fish often exhibit behavioral changes. They might become lethargic or stop feeding, making them more susceptible to infection. Fifthly, synergistic effects with other stressors. Poor water quality, for instance, low dissolved oxygen levels or high ammonia levels, often encountered in warm water, can interact with temperature stress to create a cumulative, stressful environment. This combined stress significantly increases the fish's susceptibility to diseases. Now let's focus on Bangladesh, where aquaculture plays a vital role in the economy and food security. The country's tropical climate, characterized by high temperatures and humidity, poses unique challenges for fish farmers. Summers in Bangladesh can be brutal, with temperatures soaring into the high 30s Celsius. These high temperatures can directly stress the fish, affecting their growth and survival. Moreover, they create a perfect environment for many warm water pathogens to thrive, leading to outbreaks of diseases like columnaris disease and streptococcosis. To tackle this problem, farmers can implement various strategies. One approach is to select appropriate fish species. Some species like tilapia and pangasius are more tolerant of higher temperatures and are therefore better suited for the Bangladeshi climate. Regular monitoring of water temperature is crucial. By keeping a close eye on temperature fluctuations, farmers can be more proactive in managing the stress it puts on their fish. Deeper ponds are generally more thermally stable than shallow ones because they receive less direct sunlight. Therefore, investing in deeper ponds can help maintain a more consistent temperature, reducing stress. Likewise, shading the ponds using trees or artificial shade nets can help moderate temperatures during extreme heat. Water exchange with cooler water sources, if available, can also be beneficial during heat waves. Ensuring adequate aeration is crucial in warm water conditions. This is because warmer water holds less dissolved oxygen, and fish have higher oxygen demands during warmer periods. By understanding the intricacies of temperature regulation, fish physiology, and disease ecology, Bangladeshi farmers can navigate this delicate balance, ensuring healthier fish and more productive farms. Sustainable aquaculture in warm climates like Bangladesh's is a tapestry woven with threads of scientific knowledge, practical application, and a deep respect for the delicate balance of nature. By understanding and managing the impact of temperature on fish health, farmers can play a pivotal role in ensuring food security while preserving the vitality of our aquatic ecosystems. Thank you for joining us on this illuminating journey through the world of temperature regulation in aquaculture. We hope this video has shed light on the profound impact of temperature on fish health and provided you with valuable insights into managing this critical aspect of aquaculture. If you found this information useful, please don't forget to show your support by liking this video, sharing it with fellow aquaculture enthusiasts, and leaving a comment below with your thoughts or any questions you might have. Together, we can continue to unlock the secrets of successful and sustainable aquaculture.